Right. So the point of all this, the reason why I made you guys, you know, kind of sit through this or whatever, and I know some of you, for some of you, it's very like trivial, and maybe for all of you, but again, when you're making these objects, the point is always to start with as many of the construction curves as you can come up with, and then there are various techniques for blending those curves together to get the exact kind of surface you want. And that's really the like trick. That's where all these things kind of start. Is like where are the curves like projected from? Usually it's a couple of different, you know, orthographic views, and they can get quite complex. So it's good to kind of know about that. Then the fun begins. Like once you actually kind of have a form, you know, turning that form into a solid, you know, adding in like some like holes in that form, some extrusion, some like bumps, some things like that, some like bevels. That's what we're going to be talking about next. That's where the kind of original kind of primitive form of the object starts to become this kind of smoother, more like industrial designy kind of form. That's where the rubber meets the road. Okay. So what I got for you guys, did you download on Moodle? I gave you a whole mess of Rhino demo files. You go ahead and extract those to your system here, and I'm gonna give you some tutorials tonight that you can run through on your own. But let's just run through a couple of these really quick. These are if you're not familiar with some of the commands, this is going to give you a little bit of experience with it. So I'm going to look at the rail sweep. And this is the what's known as the, you open up the file one rail sweep. One rail to lead them all. One rail to bind. That's right. Not funny at all. But okay, so the rail sweep, again, some of you guys, you know, we did some of this in Grasshopper. We're actually almost kind of like regressing backwards. Like we've seen these commands, and we never did them in Rhino, but we did them in Grasshopper first. So we did a two rail. A one rail is basically like a loft that takes place along a cross section. Okay, and it's great for making things like hoses and like pipes and railings and things like that. You know, anything. It's kind of like, you know, when you were a kid and you took some Play-Doh and you kind of push it through the little Play-Doh machine. You take a cross section and you take that along a path, and it gives you a form. There's a couple things to know about the rail sweep though that are necessary for proper execution. One, you have got to align that cross section with the end of the rail that you create. And whatever orientation that rail, that cross section has, is what's going to pull through that rail. Okay, so if you want that hose, it has to be aligned like this. And if you remember in Grasshopper, we went through all kinds of gymnastics to get the control plane to align it, you know, to get it properly oriented with it, right? So again, if you do sweep one, so the rail is the thing, and then the cross section's the other thing, you're going to get your tube. Okay, you're going to get what you expect. Okay, tube away. Now, the other thing let's sort of verify my hypothesis, right? Which is that if I take this thing and I rotate it out of plane, let's make it more severe than that. That's too good. So if I do that, I'm like, okay, that's good enough, right? Let's just sweep one. Oops. Yeah, it's gonna get weird, guys. Now, you know, maybe that's what you want, but again, you have to know what the initial commands have to be to produce the final form. So again, if that's not properly aligned, there you go. And if that's what you want, well, there you go. Okay. Let me show you something else here. And again, this is probably not you, but it's good to know. If you sweep something, and that's your cross section, look at that, right? If your cross section is not aligned with it, it does not work. It does not work the way you want it to. I don't even know what that's about, like how that ends up there. Okay? Okay. And then the second thing that you have to know about it is that a rail as we saw with two rails, right, we'll actually interpolate or morph from one shape to another. So if you see here, we have a rounded rectangle and we have a circle. Okay, and if we do our sweep one, a rail, cross section, you know, morphorama. Okay, we go from straight to rounded. Again, any cross sections that you have to be on that rail, and they have to be aligned the way that you want them to be. And again, I'm not like, this actually got me a lot when I was learning it, like, because I kind of thought they would all go to the line, or I don't know, I guess I could fudge it a bit, but you really have to keep them exactly where they need to be. And to do that, you have to make use of snaps a lot, and you could do like divide curve to get a point to snap to. Okay, that's just so you know where we're going with this. Okay, go ahead and do two rail now. A little confusing, right? Because it's actually, they call them sweep one, sweep two. This is a little bit different from what we did on the last one, right? The last one we did a two rail sweep. That doesn't look like, you know, what we did. Not necessarily. The rails are actually these guys. And the cross sections are the closed curves. Okay, so let's do sweep two. One rail, two rail, 3, 4. Wow. And now it's like a gear shift or something. Okay, that is pretty darn good. And note this. If you look at the way that they drew those lines, like look at the rails. What's that? You see that lip? When they drew it, they drew in like a bevel, okay? So it wasn't just like a straight clip all the way down to a point, right? They actually rounded that corner, probably a fillet or something like that, right? And look at how pretty like that is, okay? It's really, you know, that's actually like a detail in that, okay? And so, you know, not that you guys would necessarily do this, but, you know, if you were designing some door hardware, or, you know, looking at the way that a railing like joins something or whatever like that, do you want like a sharp edge, or do you want like this, you know, a nice kind of return on that? Like, what else is nice about bevels is how they catch light. You see that? Like that kind of highlight on the edge of it? It's really nice when you're actually making, you know, things like, I mean, just look around you. I mean, like the edge of the table, you know, the edge of the like chalkboard tray, like it's actually a nice little like aesthetic device to have a bevel on there. Okay. So anyway, think about that even when you're drawing your cross sections and when you're modeling your objects, right? Look at the bevels. This is a really efficient way of modeling this. I mean, you could go through, guys, and you know, if you didn't know this, right, and you could try to draw like each one of these like sections, you know, right? No, if you have the cross section, if you have the rail, you know, if you have the rails, you have the beginning and the end. The computer does the rest. Okay. Half the battle is like planning the curves that you're going to use to like make these objects. Okay, not everything is a loft. As much as we've kind of started with that, and maybe we've thought about that, it's not. Okay, for all the reasons we've talked about. That's beautiful. Okay, moving on. Some of these I'm not gonna talk about here. Okay, let me actually show you guys something. And then we'll follow up with the fillet edge thing here. Okay, so I'm all gushy about fillets. Go ahead and start. I'm going to show you a couple things. Go ahead and start with a box. Let's make a box. Oops. Weird. Yeah, I'm going to make a new file here. I don't want that box. I'm in Rhino 4. No, I'm in Rhino 5. Okay. Yeah, make a box in perspective. Okay. And go ahead then, and I'm gonna make a cylinder inside the box. and move it, make it like inside the box. Okay. And this is going to illustrate a couple of points here. Okay. So just, I would open up a new file. That last file has like stuff in it. Put the cylinder in the box. Okay. So there are lots of different ways that we can basically make this. I want to make this like one kind of form. Like I want this thing almost like a Lego piece where this thing kind of sticks out of it. What are the different ways I can kind of join these things together into one contiguous surface? What do we know? Nick Strickland. Come on, you can be obvious. I'm just being like, like rhetorical. Like, what are the different ways? Union is one, right? Union. Yeah, Booleans. Yeah, okay. Booleans are a whole classification. What's the like anti-Boolean? Like, what do I like us to do instead of Booleans? What does a Boolean do? Right? It takes two objects, it intersects them, it removes one, keeps the other, joins them together. Okay. So we can do that. Okay. So that's exactly what I want to do. What I actually want to do is I want to trim. I'm going to use the box as a cutting object. Okay? And I want to go in, I need to do this in wireframe, and I want to trim this object. So you can see that? You have to kind of do it from the wireframe, and I want to pick the bottom one because I don't want to accidentally pick the top one. I want to just remove that piece there. And then when I'm done, I say, okay, I'm going to delete this, this piece. Now, on the outside of this thing, right, like Bob's your uncle, like you would have no idea that that's, not, two, that's not one object. What the other thing I want to do too, though, is actually I want to trim the box with the surface. So I'm going to say this is the cutting object, and I want to trim the box. And you'll notice it's actually, I guess I can click on the inside of it. Let's see if that worked. Nope, did not. Okay. So that's actually really hard to do, right? How do I actually trim away at that box? Like, what's the right part to click? Well, here's another way to do it. I can take the intersection of the two surfaces, which is kind of like what Ryan showed us before. So I can intersect these two, and I get a curve. So I want to do like an intersect curve. And then I can hide this, and then I can trim the box using that curve. Okay.
Split the box surface with the cylinder?
Yeah. You can. Yeah. I'm just saying it's like if you there's multiple ways to do it. I mean, this is clear because it just gets you what that does is the same thing. It makes the intersection of the curve, it uses it to like make the trim. This is a nice technique to know though, because again it's like remember I said like you go from curves to surfaces to curves to surfaces. So you take the curve from the surfaces, use it to trim to make a new surface. Okay. Anybody get stuck on that? You can help up there, Blake? Yeah, I mean Ryan's right. We could always just do a split or something like that, but there's like 12 different ways to do it. Yeah. Okay. So let's go back and we'll show the two. So now it truly is. And guys, if I did this, if I said join, it's a closed pi surface. So that's actually basically a solid surface. We could mill that or we could print that. But I'm not interested in that. What I'm interested in is actually creating a smooth transition between these two objects. What I'm going to do is I'm going to do a fillet surface. Okay. And I'm going to make the radius, I don't know what my units are, but let's take a look at it. So the first surface is going to be my cube. The second is going to be my box. And crunch, crunch, crunch. It's going to produce that fillet. Check that out. Smooth. So it's kind of like a button, or like an impression that was made in it. So the fillet surface is really nice because it kind of like automates the process of making a surface. But like we saw with the offset surface, it doesn't always work. But before we talk about that, what is this like ring here? Like how would you like make that? Let's say you're trying to write the program that does that. Can we talk about the process for that? Like what is that made out of?
You just take an arc or a curve and
What did we just look at before?
yeah, sweep it.
Yeah, do a 2-rail sweep with an arc between the two. What would you do though? You'd actually have to trim this and trim this a little bit too, right? Because it started off like that. I'll show you here. Where's my redo? Yeah. Right? There's like a little bit of a trim. They actually sacrifice some of the material to get the fillet. Make sense? Okay. So yeah, I think that's right. You can think of it. I mean, I think Nick's exactly right. The way it kind of is like conceptualized is, you know, imagine you had like a little ball, and you like rolled it around this thing, and it kind of left an impression in it. You know, right? Like it kind of left its skin behind. Like that's kind of that's the fillet. And if you join all these together and you print this thing, it's baby smooth. Like that's exactly what you're going to get. Okay. What about the top of this thing? Like we want to. How would we make a nice fillety edge on the edge of this thing? What's a technique we could do? Any thoughts?
Explosion discrepancy.
Okay, I like that. Then what? Can we do fillet surface on those? Start with one. Oops. Oh, we can. How about that? You can play with different radius too if you'd like. What about this? What about this box here? This box is awfully sharp. What can we do about that? What's that? Can we do it? Let's find out. So we're going to take the top. Oh, wait a minute. These are separate little things here. Is that going to work? Can we join these together? What's that? What happens? Let's see what happens. So you want to do a fillet surface? So I do this. Okay, that does one, but then what happens?
Fillet edge.
Okay. So fillet edge, right? Oh, we can't because those don't even have edges. We could try to join these together. It does, but it doesn't show up in the render though. Yeah. Okay, so we can do fillet. We can do fillet edge. Yeah, it's not quite. That edge works. Like you can do like that, but that doesn't exactly work. Let's do fillet surface. So it only does one at a time though. Ooh. If what's joined?
If the entire thing is one solid.
Okay, if we go back to solid.
Yeah.
So if it's a solid and you say fillet edge. Okay, so I can select like these edges here.
Yeah.
Okay. Now I've got 0.25 here. Okay, so that gives me this kind of an edge. Let's take a look at it. Okay, so that's one kind of fillet. If you look at that, so it creates a sharp corner. Yeah. So if it's all been still a solid fillet edge works. Let's actually try. My settings for edge might be off here. Is that what you have, Amber, on yours?
Right.
Okay, that's the same thing I have. Yeah, it does. It does this. Is that what you? Is that you have, Amber?
No, I
No,
soft.
when I did the edge down the side.
Oh, you did all the edges.
Yeah.
Aha. So we want to click all these edges. Okay. Aha. Ah. There you go. That's pretty cool. Okay. So there's different kinds of things, right? There's like if I have two surfaces that I want to, merge together, like I can create a surface that melds them together. If I have a full surface, I can do this fillet edge if I'm pretty careful with it. It's interesting to note that if you don't fillet that third edge, that you get that sharp edge to it. So that's kind of an interesting finding.
Actually, adjust a specific fillet option.
Yeah, you can go into the into the tool, and you can also do that as well. I'll post an example later that lets you basically blend different kinds of fillets together. So this one can have a fillet of 3, and these can have a fillet of 2.
I think
Okay.
we've done it. Split your radius up.
Well, there's actually a way to do it like so that when they overlap, then you like trim it, and then you let the 3 kind of patch together. Like that's what I wanted. That's what I wanted to.
That's what I like. I stitch fillet edge, and when you click all of them,
Yeah.
like before you hit enter, like there's a little number.
Yeah, you can change the number.
Click and adjust it.
Yeah.
But it did, all of mine like seem together.
Yeah. So like this one here, and then you can like click the number. Oh, I see. Okay, so I can do next one's 3. Yeah, and then they're going to be different.
Yeah.
Yeah.
You can adjust those little arcs right when you click enter.
Oh, I see. Yeah. So you can have different size fillets on each edge, and you don't have to fillet all the edges too. So that works on this kind of geometry.
Chamfers are the same thing.
Yeah, you can do that with chamfers too. Yeah.
So, what's blend
What's what?
edge? Yeah, what's blend edge?
Blend. Yeah, we're going to look at that in a second here. Okay. Okay. So. Oh, actually, let me show you something else here too. Okay, so we've got this kind of formation, right? Let's go ahead and in top view, I'm going to do a wireframe. I'm going to draw a square. And you have to, and then move it in front view so it's above the form. Okay? So draw a square or a circle or something like that in plan view above one of your boxes, and then move it up in the axis. Everybody got that? So you can create curves on a surface by intersecting two objects. We've seen a couple of examples of that today. You actually want it to be smaller than the surface. You want it to be like that kind of. The other thing you can do is you can take this thing like a cookie cutter, and you can project it. So you do a project. And I think I showed some of you guys how to do this with topo. So if you have like some like topo, so I basically like I took that line, I took that thing and I projected it, and it's like stuck to the surface, basically. Okay? Then what I can do with that is I can do like a split. So I can split this with that curve. So now I've got this piece. Okay? And then I can actually extrude. Well, I can remove this, and then I can extrude what's left over. To create a like a pocket in there. Okay. And then I can join all these back together again. And then if I want, I could do that fillet edge again. Right? With my radii. And I can fill these. Oh hell, why not just do all of it? Whoa. That might be a bit much, but too much radius there. But so then you can get like embossing inside of a figure. So you can make stuff that like sticks out. You can make stuff that goes into something like that. That command works really well because it works with any kind of you take a 2-dimensional shape and a 3-dimensional shape, and you can combine them together. So like let's say this sphere is like your topo. Okay? And I'm gonna just make my mark on the world here. Oops. Too much. Yeah, so I'm just gonna do. Whoops. Okay, join those together. So this is my let's say it's a road or something like that, right? Why not? And it's gonna go above. Again, it has to be above it because it has to be able to project into it. So project. I'm gonna project this into this, and then if you look at the geometry, it's actually going to map to that. Okay. Then I can do things like, I can split my surface again. And this would be how you would like extrude the surface. It's one way to get. I didn't do it as. But anyway, it's one way to get your roads into your topo. Then you extrude them by some, or you extrude them down, and then that's how you get your curves. Okay, and look at how smooth that is on that surface, and that would apply. Now think about this. You do fillet surface, and I can do a radius that's pretty small. Oops. Well, anyway, you can basically fillet the one surface to the other. It's not working too well, but oh, I see, because it's polysurface. But maybe you could do fillet edges, and then that would look like it's embossed on a surface. So if you have like a label or something that's on your device, or a button that follows the contour of it, you can project that 2-dimensionally onto the geometry, or even just do an intersection of it, and then extrude it, and then fillet it, and you've got that nice, button. We'll talk more about this, next time or whatever. But anyway, so like project is another really useful technique. Okay. Okay, I'm missing the file for this. I'll post it up later. But Dakota was asking about blend. like how a blend works. Let me give you an example. So draw a surface plane, and then go ahead and copy it. And then move one of them up in some axis here. So you got something like this, basically. And actually, you probably want to move this a little bit this way. This is a very, very simple example, but. Whoa. They're flipped. Man, that's no good. That's not right. Okay, so do it that way. So the blend surface takes two surfaces and you have to get the order right, otherwise you flip it. But you can essentially adjust the tension of one side or another, so you can get the right kind of and so this kind of creates, you have a bevel condition and then like a reverse bevel condition on one of these things, and it's dependent a lot of times about them being similar geometry. But a blend again gives you control over both of those curvatures. Again, if you're having trouble with that surface, sometimes things generally have like a direction to them. The direction that the curve is drawn or the direction that the surface gets drawn, and so sometimes you have to either like flip the object, or you have to like play with the direction of it. In this case, it looked like I had to do this one first and then that one because of the way that the polygons get drawn. But you can also experiment with different settings for some of these, so you can get one that's actually meant to be. So one's always tangent to the other, or there's different levels. There's different levels of like continuity between these, and we'll talk about the continuity a little bit more next time. But okay, so. Can experiment with these.
Can you move those control points?
These here?
Before we hit OK?
Oh yeah. Yeah, they give you exacting control, so you can have one that's a little bit more out than the other one is. So blend gives you a lot of nice little like parameters that you can actually control, especially in Rhino 5. This is nice. Some nice stuff here. So it takes a lot of the difficulty. So if you were going to do this another way, right, you'd actually have to draw the like cross sections. You'd probably do a rail using the edges with the cross sections, but the blend tool like packs it all in the same tool. So surface blends are also your friends here. Okay, it's most of what I wanted to cover here. I don't want to throw too much at you, but the kinds of things, again, that I want you guys to be looking at for your objects are and I'll post some requirements, I guess, but basically like industrial objects that have several parts. If you had, I don't know, I mean there are things I've had people do like interesting like water pots, like for like watering plants that have like because the water pot's gonna have a handle. Right? So you have like a lofted contour that has to join the revolved surface that has to join the spout. So those are three like complex parts that you have to think about. I've had people make their like mice, if they're interesting mice. Again, what I would like you guys to do, I have you guys are the advanced class, it's advanced digital methods, and so like this is not too hard like to do. You have to get the curves like pretty like precise and all. It's not very complicated. Okay, I would say, right? This is though. This has buttons. It has like some holes in it. Right? So I don't want things like this necessarily. I don't want your iPhone. I really don't.
So things that aren't symmetrical.
Things that aren't symmetrical. Symmetrical is okay as long as there are parts. Like, you know, again, if I think about, I've had someone do like a really interesting water bottle that had like different. Some of it was rubber, some of it was actually like aluminum. It had a lid, it had a screw, it had a piece to it, like that kind of thing. I'm fine with. Okay, multiple parts, because there's going to be like a seam. And I want you to try to model as much of it as you can. So like model the seam between the materials. There's going to be a little bit of a gap that like runs between it. Okay? So like challenge yourself. Do the best you can. Do it as quickly as you can. We'll troubleshoot these on next Tuesday. Okay? Tonight I'm going to post a bunch of tutorials that are from like McNeil. Okay? I'm not sure we're supposed to have them, but we bought the software, so I feel like we're okay with that. They're like training materials from McNeil. They are going to take you through a bunch of industrial objects like toothbrushes, and I think there might be a drill or something like that, and they're exactly the kinds of things that we want to be going through. So, you know, think about some of the basic ideas that I talked to, because what they don't do is they don't give you a process for understanding like how to break down an object. Okay, what they do is say, this is how I make a toothbrush, you know, right? But like, how do I take that and make $1 million yacht, you know, for Steve Jobs or whatever, right? There's a big gap there. So what I want to talk with you guys about is the process. That's going to give you more of the technique stuff that I haven't been able to really like talk about today, okay? So bring your questions. If you have trouble, what I want to see most of all Tuesday is a three-dimensional, like the contours of this object, right? Like three-dimensional. We can worry about the surfaces when we all get together if you're having trouble getting the continuity and things to go right. But I want as many curves as possible with the amount of precision that you can give me as possible. Okay? So it's like you have your like wireframe, literally like a wire model that you could paper mache or whatever. Bring that to me Tuesday. Okay? And then we'll work this thing out. Make sure your object is interesting to you, because you're going to be spending a couple of like weeks with it. Make sure it's complicated enough. Again, we're going to be breaking out the parts of this thing, like taking these like pieces apart. We're going to be cutting them up. We're going to be mirroring them. So give yourself a fair, interesting object to work with. Okay, and that's it. Thank you, guys. I would do this. This is awesome.
I'm gonna do one of those the whole time thoughts.
Yeah.
So,
Nice.
got all the pieces that move that it would.
Yeah, you need to do a really complicated one. You're a ringer, man.